Hello. Today's lesson, or this lesson, is 2.1 notes. It is about the basics of sets. So first, we're going to look at some terminology and define a few things before we move on to actually looking at examples. So since it is the basics of sets, we're going to define what a set is. And a set is a collection of objects that can be clearly defined. So something that we can clearly define. Elements or members, they can be called either one, are the objects in the set. Universal set, which is symbolized by a capital U, is a set that contains all the elements for any specific discussion. So that's all of them. A well-defined set means that contents can be clearly determined. That is, exact members can be specified. And we're actually going to look at this well-defined first here with our first example, which is, are the following sets well defined? So A is collection of part-time and full-time students enrolled at TCC. So are we able to clearly determine who are the students that are part-time and full-time enrolled at TCC? Yes, we can. This is a well-defined because we can say exactly, we can list all the students that are enrolled as part-time and full-time. Now for B, collection of tall students in the 12th grade. Well, here, if we look at the word tall, what does that mean? Tall, if you're just thinking about the word tall, it means different for all of us. For some of us, 5'10" can be tall. For some of us, 6'4" is tall. So this is not a well-defined set. If we had an exact height here, then it would be well-defined. But the word tall does not, it doesn't give a specific and a specific description of, you know, what the exact members are going to be. So we're going to leave it like that. Okay, then for sets, we have different formats. We have word description, roster method, and set builder method. So, and we're going to look at examples here. Word description, just like it says, it uses words. So you use words to describe. Roster method is a listing, or you're listing the elements of a set inside a pair of braces. And braces look like this. So you're in roster method, you're listing the elements inside these braces. Set builder method is a formal statement that describes the members of a set written between braces. Okay. So we're going to look at, like I said, these are just a description or definition of what each of these formats are. We're going to look at examples. First, before we do that, we're going to define natural numbers. Natural numbers, their symbol is a capital N. And they are what's called our counting numbers. So counting numbers 1, 2, 3, 4, 5, 6, 7, and so on. Those are our natural numbers. Now we have this here. So we have the two separate ones, and we need to define what the difference between those two are. This one is x is less than 5. X is less than 5. So the 5 is not included in it. Included. This one here with the line underneath, it has the x is less than, but it has the line underneath which means equal. So this one is x is less than or equal to 5. So that line there means equal. So in this one, number 5 is included. So x is less than 5 is this one here. And x is less than or equal to 5 is this one here. Okay, so now we've defined a whole bunch of things. Let's look at an example. So now we're going to describe each set. So here's the description. Basically, the word description is this. It of course has some numbers, so this is not fully a word description, but it's at least part of it is with the x is a natural number. So our roster method is listing the elements of a set inside a pair of braces. So what we're going to do here is we're going to look at our description. X is greater than or equal to 6. X is a natural number. So we have that equal sign here, which means that we start with the 6. X is greater than. So 6 is the smallest. We do need to open our brace. X is a natural number, so our counting numbers 6, 7, 8, 9, and so on. We're not going to list all the numbers because we would be here forever. What we're going to do is we're going to put a comma and then 3 dots, which is called the ellipsis. That means that this pattern continues. So 10, 11, 12, 13, 14, and so on. And we close the brace. That is our roster method. Now for our set builder method, the way we're going to write it is, and we're going to use we're going to call this set A. So set A equals, we're going to start with a brace, X, our unknown is X, and a straight line. X is such that, this means X is such that, X belongs to natural numbers. Remember, natural numbers are the ones with the capital N. This means that it belongs to. So X belongs to natural numbers, and X is greater than or equal to 6. That's this one. So here's the natural number, and then it's X is greater than or equal to 6. And we close the braces. We're first putting the natural number because we do the like a kind of a bigger in set builder method first, and then describe it more over here. Okay, next one. Now we have X is less than or equal to 4. X is a natural number. So x is less than or equal to 4. So our largest number is going to start with a 4. And then we're going to go down 3, 2, 1. It's natural numbers, so it ends there. So 1, 2, 3, and 4 are the only numbers that belong to this set because x is less than or equal to 4. Now for the set builder method, we're again going to call this, we could call it a set B as well, so that we're not confusing that it's the same one. Set B equals braces open. Again, our variable is x. If it was something else, we would write whatever the variable, the letter is. X is such that, again, x is a natural number, and x is less than or equal to 4. And we close the brace. Okay, next one. Now we have two inequalities here. So we have 2 is less than or equal to x is less than 6. X is a natural number. So again, we're talking about our counting numbers. So 2 is less than or equal to. So 2 is part of this set. X is less than 6. So that means that we're going to go up to 6, but 6 is not included. So 2, 3, 4, and 5. Again, 6 is not included because it doesn't have the equal sign. Set builder method. I'm just going to put this as a set S. And these are not defined anywhere. So I'm just making them up as I go. So you don't have to worry about that. You will, in some problems, it will actually say which one is which. Okay, again, we have x is such that x is a natural number, and now we're going to do this inequality here. 2 is less than or equal to x is less than 6, and close the brace. Okay, so there's the first page. Now let's move on to the second one. Let's look at the examples first before we move on to, or we're going to look at, I mean, basically they're going to describe or and for us. So if you're looking at the description, this one has and this one has or. So our first description, and now you can see that this is a full word description. Natural numbers greater than 5 and less than or equal to 8. So natural numbers greater than 5, that would mean that 6 would be the first one. 7, less than or equal to 8. Since it has that equal to, 8 is included in it. And that is it. That's it. And now, please, please, please make sure that you do the braces, because that does mean that it's a set. Even though, as you can see, I can't even draw the braces properly. You do need to mark when you're marking a set that you have the braces there. It is not a set if you don't have them. So make sure that you do that. Okay, so that was the roster method. Now we're going to write the set builder method. So again, we're just going to use, for example, A equals and open braces. I'm actually going to use a small a on here for the variable, since it really doesn't define it here. It doesn't matter. So I'm just going to use an a. Most of the time we use x, but I'll show you that we can use others as well. Again, natural numbers. So a is a natural number, and so greater than 5, so 5 is less than A, less than or equal to 8, less than or equal to 8, and we close. Notice that greater than 5, A is greater than 5, and less than or equal to 8. So this is our set builder method. Now, let's look at the next one where we have the word or. Natural numbers greater than 8 or less than 6. Greater than 8, that would be 9, 10, 11, 12, and so on. Less than 6. Less than 6 would be 5, 4, 3, 2, and 1. And parentheses in both of them. Again, natural numbers are counting numbers. Greater than 8. 8 is not included, so we start with 9 and move forward, and it will keep going, going, going. Less than 6. So 6 is not included. 5 is the largest one. 5, 4, 3, 2, 1. And that's it. Our set builder method, let's use capital B. And let's use small b here. We are just showing that b is the variable. B is such that b is part of the natural numbers, and because now we're going to go into describing this. B is less than 6 or B is greater than 8, and close the parentheses. So we have to mark them separately because there's really nothing we can, they're not in between. Like we see there's a gap of numbers. If we think about all our counting numbers, we're missing 6, 7, and 8 here because they're not part of this description. So we can't combine these two like we can this one. We have to write them separately. So there's your and here's your or. Okay, next one. We're going to define the empty set, the null set. The empty set can be called a null set. It is the set which contains no elements. And there's two ways of writing it. We can write braces, and there is nothing inside the braces. This is an empty set. If you write something inside the braces, for example, a 0 is an element, it contains an element then. This means an empty set where there's nothing in it. Or we can do an O with a diagonal line through it. This means an empty set as well. So either one of these two is the correct answer for if it's asking for an empty set. Next, we have an example. So X is such that X is a natural number greater than 6 or less than 2. So we are identifying the set which represents the empty set. The set which represents the empty set. Empty set. So, okay, let's try this again. X is such that X is a natural number greater than 6 or less than 2. So, can we write numbers inside the set? Let's see. So we're going to start with the brace open. Greater than 6. Well, greater than 6 would be 7, 8, 9, and so on. Less than 2 would be 1. And now I left a bigger gap than I'm in 2. And that's it. So if we look at this, we were able to write numbers in here which means that this is not an empty set. It has these elements in it. Okay, let's look at the next one. B. X is such that X is a natural number less than 6 and less than 2. Now notice that this one again was or, either or. This one is less. I'm sorry, less than 6 and less than 2. So it is less than 6 and less than 2. We can't, so the numbers 5, 4, 3, and 2 and 1 are all less than 6. We could write them here, 5, 4, 3, 2, and 1. They are all less than 6. But we have to and, meaning it has to include less than 2. So the only number that is less than 2 is 1. So the element in here is 1. Well, we have a 1 in there, so this is not an empty set. Okay, let's look at this next one. C. X is such that X is a natural number greater than 6 and less than 2. So again, remember, and means that we've gotta, it has to be defined by these two when it's and. Or can be either or. So they don't have to include both of these. Where and, it has to be included. Greater than 6, less than 2. Well, there's no such number that can be greater than 6 and less than 2. Because the only natural number that is less than 2 is a 1. But then greater than 6 would be 7, 8, and so on. So this one is an empty set. Okay, let's look at D. Now, we have a 0 inside the braces. And this was the thing that I warned you about. This is not an empty set. It contains the 0. So it is not an empty set. This one, on the other hand, we already defined that the symbol here means that it is. So this is an empty set. Well, what about if we take this symbol and put it inside the braces? It is not an empty set anymore. It has that symbol in it. So the only empty sets that we had here was C and E. All the others have a symbol in them, and symbols or elements in them. Symbols or numbers, so those are all elements or members, whichever one you want to call. Okay, let's look at the notation. So this means is an element of a set. This little kind of an E means is an element of a set. So how do we write it? For example, I can put 5 is an element, and then I'm going to write a set of numbers, which are, for example, 3, 4, 5, 6, and 7. So 5 is included in here, so it is an element of a set. When we draw a diagonal line across it, it means that it is not an element of a set. Not. So if I do 5 is not an element of this set, I would, for example, have the elements 1, 2, 3, and 4. 5 is not part of it, so we can write it like this. 5 is not an element of this set. Okay, let's go and look at the following examples, true or false. So 12 is an element of this set. If we look at this 1, 2, 3, And then we have those ellipses. So this means that it continues 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 is the last one since we have 14 marked here. So when I listed those numbers, I did list 12. So this one is true. 12 is an element of this set. 8 is an element of this set. Well, if we look at the set, we have 1, 3, 5, 7, and then it ends at 19. All of these are odd numbers. 8 is an even number. So 8 can't be a member in a set where there's all of them are odd numbers. So this has to be false. Negative 8 is an element of natural numbers. Nope, it is not. Negative 8 is not a counting number. 2.5 is not an element of natural numbers. That is true. Remember, it's only the whole numbers that we're using. 2, 3, 4, and so on. So 2.5, when we have a decimal, that is not part of the natural numbers. Okay, so let's move on to page 3 here. We have another definition. Make sure that you memorize these definitions because you will need them, and it will be easier to do your assignments and everything. So, cardinal number, the number of distinct elements in a set. So, however many elements we have in a set, that is our cardinal number. And now that is represented by a small n with parentheses and whatever the set is. I'm going to write the set as a capital S, so the capital S goes inside the parentheses. And I'll show you how to use it in this next example. So our example, find the cardinal number of each set. So the cardinal number, a small n, and this is set S, so the S goes inside the parentheses, equals, we have 1, 2, and 3 members here, or elements. So the cardinal number of the set is 3. Our next one, again, we have a set S. We have 1, 2, 3, 4, and 5 elements here. So the cardinal number of set S equals 5. Next, we have a set T. So the cardinal number of set T. Well, this says that it's an empty set, so that means that our cardinal number is a 0. Again, we have a set S. So the cardinal number of set S. Now, remember that this has one element in there. That's that 0. So this, the cardinal number is 1. Okay, next we're gonna define a finite set and an infinite set. So in a finite set, the cardinal number is a natural number or 0. Infinite set, the cardinal number is not a natural number or 0. So we're gonna do an example with these. Are the sets below finite or infinite? Set A has 1, 2, and 3. So what we're looking for here is the cardinal number. So the cardinal number of this set A is 1, 2, 3. It has 3 elements, so the cardinal number is 3. So natural number or 0. So this is finite. B. So can we actually write the cardinal number of this set B? It has the ellipsis, which means that it continues 4, 5, 6. We don't know where it ends, so we don't know how many what the cardinal number is. We don't know how many elements it has, so this is an infinite set. Because we don't know what the cardinal number is. We don't know where it stops. C, set C, the cardinal number of that set, well, it doesn't have anything in it, so that's 0. The cardinal number is a natural number or 0. So this has to be a finite because it is 0. Okay, next, one-to-one correspondence. Sets A and B are in a one-to-one correspondence if each element of A can be paired with exactly one element of B and vice versa. Exactly one element. One-to-one correspondence. So which sets have one-to-one correspondence? So we're looking at these two here. And now, the easiest way to figure it out is just to draw a line from here. So we have these two, these, and these. Each element of A can be paired with exactly one element of B. So this does have one-to-one correspondence. Now, when we look at these two, when we draw these lines, we can see that 5 is left over. So we cannot pair each element of A with exactly one element of B and vice versa. So we have to be able to do it the other way around as well. So this one is a no. It does not have one-to-one correspondence. Okay, this next one, let's keep drawing those lines. And again, A has W that we are not able to pair with anything in B. So this does not have one-to-one correspondence. Okay, next definition is equivalent sets. Equivalent sets. Sets A and B are equivalent if they have the same cardinal numbers. Same cardinal numbers. So let's look which sets are equivalent. We have S and T. So let's look at the cardinal numbers. The cardinal number of S is 1, 2, 3. And the cardinal number of T is 1, 2, 3. So the cardinal numbers are equal. This means that these two are equivalent. So notice we are only looking at the same cardinal numbers here. Okay, our next one, the cardinal number of S is 2. And the cardinal number of T is 1, 2. These two are equivalent. Or the cardinal numbers are equal, which means that they are equivalent. C. Again, we have the cardinal number of S is 2 and the cardinal number of T is 2. Both of them have 2 elements. So the cardinal numbers are 2 and these are equivalent. So remember what this equivalent means, because on this next page we're going to talk about equal sets. Equal sets. So set A is equal to set B means that A and B contain exactly the same elements, regardless of order or repetition. So we would write set A equals set B. So equivalent meant that the cardinal number is the same. Equal means that they contain exactly the same elements. So if we look at this one, here. We have set S that has 1, 2, and set T that has AB. Well, the elements are not the same, so these are not equal. Here in B, set S has 1, 2, and set T has 1, 2. So these are equal. So set B is equal because they have the exact same elements. Now, let me do a couple of other examples here just to show you. So if we do set S that has 2, 2, 3, and 3, and we have set T that has 2, 2, and 3. So notice they have the similar or the same elements, 2, 2, and 3, but set S has this extra 3 as an element. So these are not equal because S has that 1, 3 that T doesn't have. These are not equal. Now let's look at this example. So we have set S that has 1, 2, 3, and 4. And then we have set T that has the elements 4, 2, 1, and 3. Well, it doesn't matter what order they're in. If we look at the elements, we have 1, 2, 3, and 4. We have the exact same elements here, so these two are equal. That is what it means regardless of order or repetition here. Okay, let's look at the example. Are the sets below equivalent, and then are they equal? So we have a set A, B, C, D, and set B, 1, 2, 3, 4. Well, if we look at the cardinal numbers, the cardinal number of set A is 4. The cardinal number of set B is 4. That means that they are equivalent. We're looking at the cardinal numbers. Are they equal? Do they have the exact same elements? No, they don't. This one has A, B, C, D, and this one has 1, 2, 3, 4. So they are not equal. Next one, set A, X, Y, and Z, and set B has W, X, Y, and Z. Well, the cardinal number of set A is 3. It has the 3 members. B has 4 members. So the cardinal number of B is 4. So these are not equivalent because they don't have the same number of elements. The cardinal numbers are not the same. Well, are they equal? X, Y, and Z, X, Y, and Z, but B has that W that set A does not have. So these are not equal either. Next, we have set A, 1, 2, 3, 4, set B, 1, 2, 3, 4. Well, both of these have cardinal numbers of 4. There are 4 elements in both of them. So these are equivalent. Well, are they equal? 1, 2, 3, 4, the exact same elements. Yes, they are equal. So let's look at the challenge. Determine if the situation below is possible. If it is, provide an example. If not, explain why not. So, can 2 sets be equivalent but not equal? Equivalent but not equal. Well, if we look at this, we have a yes here in the equivalent but not equal. So this would be our example. So yes, 2 sets can be equivalent but not equal. If we have a set A that is A, B, C, and D, again, equivalent means that it has to have the same amount of elements. The cardinal number has to be the same. But they are not equal because they don't have the same elements. Now, can 2 sets be equal but not equivalent? Well, there is no way that we can have a set that is equal but not equivalent, because if we have a set that is equal, it has to be equivalent. It has to have the exact same amount of members as well. So there is no way that we can have a set that is equal but not equivalent. Okay, so this is it for 2.1 notes. And again, a friendly reminder, if you have any questions, please feel free to ask me, email me, or ask me when we do our live session. Anytime, do not hesitate to ask if you have any questions. But this is it for now. Bye.